we have integral of rational fraction. Degree of numerator is the same like degree of denominator. So first we have to do long division. We have to divide x squared by 5x squared plus 12. X squared divided by 5x squared is 1 over 5. Now we have to multiply 1 over 5 times 5x squared is x squared. 1 over 5 times 12 is plus 12 over 5. Now we have to do subtraction. X squared minus x squared is 0. We don't have here, so it's like 0 minus 12 over 5 is negative 12 over 5. So now, because we cannot divide negative 12 over 5 by x squared, now so we have to rewrite our integral to form. We get 1 over 5 and we have negative, we can put first negative 12 over 5 over 5x squared plus 12 with dx. So this is equal integral of 1 5 we can calculate is 1 over 5x, and we have minus integral of this whole expression we have to now calculate, so we can take this constant before integral, so we will have 12 over 5 integral of 1 over 5x squared plus 12 with respect to x. Next, because we have 5x squared plus 12, so it means we need to change this integrand to form, let me write this here, integral of 1 over z squared plus 1 with respect to z. This is equal arc tangent of z plus constant c. So first let me rewrite our denominator. We have 5x squared plus 12. To get this form, first I will rewrite this to square root of 5x to second power plus 12. Next, because I need to have here 1, I will factorize 12. So this is equal 12 times, and in first expression I will have to put square root of 5x square over 12, and I will have plus 1. So this is equal, now I can change this, 12 we have to copy, and we have square root of 5 over 12 x to second power plus 1. So let me rewrite our integral to this form. So will be, first we have to copy 1 over 5x, and we have to put minus 12 over 5 integral of 1 over, and we have 12 times, in brackets will be square root of 5 over 12 x square plus 1 dx. Now we can take this constant before integral, so we can reduce 12 and 12, and what else? We can substitute now square root of 5 over 12x by u. So we will have square root of 5 over 12x is equal u. So now we have to find derivative of both sides with respect to x. So it will be square root of 5 over 12 is equal du to dx. Now I multiply both sides by dx. So we will have square root of 5 over 12 dx is equal du. Because we have dx only here, so now I have to divide both sides by square root of 5 over 12 to get dx. So we can reduce square root and we have that dx is equal, we can flip this fraction with square root, so will be square root of 12 over 5 du. So now we have to come back to our integral. This is equal 1 over 5x minus 1 over 5 we have, and we have integral of 1 over square root of 5 over 12x. We will substitute by u, so we have u squared plus 1, and dx is square root of 12 over 5 du. So this is equal. We can take this constant before integral. So we have 1 over 5x minus 1 over 5 times square root of 12 over 5 integral of 1 over u squared plus 1 du. Integral of 1 over u squared plus 1 is equal arctangent of u. So this is equal, we have 1 over 5x minus, and we can change this to square root of 12 over 5 times square root of 5, and we have arctangent of u. Have to add constant. I forgot to add constant when I did integral of 1 over 5. So I can put together constant plus constant, give me still constant, so will be plus c. So this is equal. Now I have to come back to substitution. U is equal square root of 5 over 12 x. So we have 1 over 5x to copy minus, and I have to reduce square root from denominator. We don't like to have square root in denominator, so it will be times square root of 5. Numerator and denominator we have to multiply. So we will have minus square root of 12 times square root of 5 is square root of 60 over 5 times 5 is 25 arc tangent, and u is square root of 5 over 12 x plus constant c. So this is equal, let me rewrite this one more time. We have 1 over 5x minus square root of 60 over 5, 25 of course, arc tangent, and I will multiply numerator and denominator by square root of 12. So we will have, in denominator will be 12, and in numerator we will have square root of 16x plus constant c. This is my solution.